Have you ever wished that your database would just tell you what queries were slow, and then on top of that, tell you exactly what you needed to do to fix those slow queries? If so, Postgres on PlanetScale has some of these tools to do exactly that. So let's take a look at PlanetScale Insights over here. And there's a bunch of awesome things that you can use Insights for drilling in on performance. Basically, anytime you have a query that's performing poorly, this is the place that you should go to try and identify why. You can see lots of nice graphs for your query latency, and you can sort of drill in on different time zones. And you can also go down and look at data on a per query level, which is really useful. So sorting by rows read over rows returned is a really great way to figure out what queries might be performing slowly, or just looking at which ones are taking up a lot of CPU time. Tons of things you can look at here, but the thing I want to focus on today is recommendations. Now, we've already had recommendations for a while on Postgres, but we have some new ones that we've introduced recently that are actually powered by AI, powered by LLMs. So if you click on your recommendations, you can look at all of the ones that PlanetScale has detected and is recommending changes for you. And the new thing that we've introduced recently for Postgres specifically is recommendations to add indexes. Now let's go look at one of these just as an example. We've had index recommendations for a while on the Vitesse side. However, the ones that we're introducing here are actually even more sophisticated than those ones were, because we're not just looking at really basic queries with only ands in the where clause, because what we're actually doing in this case is we're taking your queries that are anonymized without real inputs, as well as the related schema, and passing it into an LLM to give it the ability to think through, not just for single tables, but for the query as a whole, what indexes could be added to make this more efficient. So here's an example of one recommendation, and it's for a pretty basic query. I've got this select count as item count and a very simple where clause. And essentially what happened is this detected that it hit the thresholds for optimization, or for sending it in to the engine that we have for checking if a query can be optimized. And it noticed that it has a high rows read over rows return count. And based on the analysis, it figured out, and this is actually using an LLM, but then confirmed using an explain in Postgres. Postgres estimates that if we applied this index on this table, we could get a 45x improvement in the performance of this slow query that I have. So this is one that if I wanted to, I could copy this and I could go apply that DDL to my database right away. If I decide, well, I actually don't want to do this, maybe it's because I know something that the recommendation doesn't about my database, or maybe it's because, hey, this is a query that I only run once a week or once a month, and I don't really care about it being that slow. I could give a reason. I could just say, I don't run this very often, which you still might consider doing that. But either way, this one I'm just going to go ahead and close that out just so you can kind of see how that works. So now I have 5 open recommendations and 1 closed. But let's look at something a little bit more involved here. So here is one that these queries, there's actually 2 queries that it is recommending sort of combined, like, hey, I could speed up both of these if you apply this index. And these are a little bit more complicated queries, and you can even click on these to bring it to a query specific page where you can look at, for this specific query, what are the latencies over time, what are examples kind of where this query has run and performed poorly. This is one that takes like over 700 milliseconds regularly, so this is one you'd probably want to eliminate from your query workload. And so going back to this, we can see it's detected that for both of these, we could get a really significant speed up, again, based on Postgres's explain engine. And it has the schema recommendation for what I would need to change, the index I need to add right here. So in this case, I would probably want to apply this, and I would do this by, at the right time, right, opening up a shell and applying this schema recommendation to my database. And then going forward, and that query executes, I would see a significant speed up improvement. So this is a really, really powerful tool, because what it means is we're essentially proactively looking at what queries are going slow, particularly ones that we think could be sped up by adding an index. So we've got this feature working for you in the background so that as you evolve your schema, as you make database changes, as you introduce new types of queries to your workload, we're looking at those and seeing, can you add indexes to make this better? Now, the interesting thing is there are other reasons a query can be slow besides lack of indexes. So you might wonder, well, okay, I have a certain amount of recommendations that can come in, but how do I identify slow queries or problems with my database that aren't related to schema recommendations that we have in PlanetScale? Well, a couple of sort of little quick tips is, again, Insights is an extremely powerful tool as a whole outside of just the recommendations. So I recommend coming in regularly and sort of assessing. For example, if we just looked at the P95 right here, this actually doesn't look too bad, right? The P95 is mostly like under 1.4 milliseconds, which is great. But then once we start showing P99 and even P99.9, we start to see, okay, there's definitely some problematic queries. And these are ones that have probably some recommendations for, but you can also go down and do some manual digging yourself like we showed here. I think one of the most useful things to do is look at rows read over rows returned. This essentially indicates a query that's needing to scan and look at a lot of data if this number is high, but not necessarily return a lot of that data. So potentially wasted IO that's going on. But there's a ton of things that you can filter by in these options. You could, for example, like maybe you want to look at what queries are not hitting my in-memory cache very frequently. So we have stats on the blocks that are getting hit, the blocks that are getting read. The block cache hit ratio is probably just a good one to look at here. So in this case, the hit ratio is basically 100%. And the reason for this is a small database. It's only like 3.5 to 4 gigabytes, and I've got 8 gigabytes of RAM on this instance. So this is all hitting memory. Small little example. But if you have a bigger database where it doesn't all fit in RAM, you might notice that some queries are doing a lot more IO than others, and maybe those are things that you can optimize. A bunch of other things that you can look at. So I think those two are good ones to look at. It's also interesting to look at things like P99 and max latency, right? Because these just show you there could be queries that run well a lot of the time, but there's outliers that run really slowly sometimes, like we can see with this one, or even over here, right? A max latency of 161 milliseconds or 115 milliseconds. That's really not great and probably something that you'd want to try to eliminate if you can. So those are our new Insights recommendations. Give it a try. Let us know what you think, and I hope you have fun making your database fast.